So the next method of simplifying we need to look at, we're going to call rationalize the numerator, which I realize sounds a little weird because you guys are probably used to rationalizing the denominator, but just go with me on this. We're going to take a look at the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. What's the first thing that we need to do here? I hope you said the first thing needs to be plug in 0, because if I get a number like 2 over 3, that's my answer. I don't have to do any other work. I'm going to go plug in. I'm going to get the square root of 0 plus 1 minus 1 over 0. 1 minus 1 over 0. Yeah, this is 0 over 0. This is that form that says I need to do some simplifying. I would try to factor and cancel, but that's not really going to work with that square root in there. Usually when we have a square root in our problem, we're going to need this rationalize the numerator answer. The point of rationalizing something, a numerator or a denominator, just involves being able to move that root to the other part of our fraction. I can rewrite this problem by multiplying the top and bottom by the conjugate of the numerator. I'll show you exactly what that means in a moment. I'm going to rewrite this by multiplying the top and bottom by the, what we call, conjugate of the numerator. I'm going to rewrite this thing by multiplying the top and bottom by the conjugate of the numerator. So this problem is going to equal the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. Maybe, possibly, hopefully, from either pre-calc or algebra 2, you remember that the conjugate of something like this with our root as part of the sum or difference involves having the same pieces with the opposite sign in the middle. I am going to multiply the top and bottom by the square root of x plus 1 over the square root of x plus 1 plus 1. Now please watch this multiplying very carefully. Up top, I need to go and I need to FOIL that thing. This is going to give me the limit as x approaches 0 of, well, when you multiply a square root by itself, the square root part cancels, you're just going to get x plus 1. Square root of x plus 1 times 1, well, that's square root of x plus 1. Negative 1 times the square root of x plus 1 is negative the square root of x plus 1. Negative 1 times 1 will give me negative 1. In the denominator, it looks like it's in a good form for me to distribute the x, but I'm actually not going to do that, and you're going to see why in just a moment. I'm going to leave the denominator factored as x times the square root of x plus 1 plus 1. Well, I have some simplifying I can do up top, and actually this is pretty nice. Those two square root pieces, those are going to cancel, and the 1 and the minus 1, those are going to cancel as well. So I'm going to get the limit as x approaches 0 of x over x times the square root of x plus 1 plus 1. What do you think we should do next? I really hope you said, well, either plug in. I guess we could go plug in, but if you do that, you're going to get 0 over 0. Or, hopefully you could look at this and realize we need to go and cancel those x's. This still kind of sort of becomes a factor and cancel problem. And that's also why I didn't distribute the x in the denominator, because if I leave it out front, it's easy to cancel. I'm going to get the limit as x approaches 0. Again, make sure you're being good with your limit notation. 1 over the square root of x plus 1 plus 1. I think I'm ready to plug in. I know I'm not going to get 0 over 0 because the top's already just 1. I'm going to get 1 over square root of 0 plus 1 plus 1. That'll give me 1 over 1 plus 1. I'm going to get 1/2. And again, remember in terms of the notation, limit, 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 limit. But once I start plugging in that 0 where the x is, no limit symbol, no limit symbol. Answer is 1/2. There really aren't too many variations to this rationalize the numerator idea. They all kind of work the same way. So I'm going to give you one other problem, and I want to see how far you can get on your own with this one. It's a tiny bit different, but same basic ideas. Limit as x approaches 7 of the square root of x plus 2 minus 3 over x minus 7. If you're watching this on YouTube, push pause and see what you can do. If you're watching this through Edpuzzle, see what you can do and send the answer in when you're all set. So I'm going to start the way I always start. I'm going to plug in my 7, square root of 9 minus 3 over 7 minus 7, 0 over 0. So I'm going to go and I'm going to rationalize my numerator, and I'm going to multiply the top and bottom by the conjugate of the numerator. I'm going to get this, and just for good measure, we'll stick some parentheses around all this stuff. And we're going to start FOILing. This is going to give us the limit as x approaches 7 of, okay, this root times this root, the roots cancel, you got x plus 2. This times, oh, this is going to be unpleasant. This root times 3 is just going to give me 3 root x plus 2. Negative 3 times this root gives me negative 3 root x plus 2. Negative 3 times 3 minus 9 over, just like in the last problem, don't actually distribute, or in this case FOIL, in the denominator. Leave it written as x minus 7 times square root of x plus 2 plus 3. I'm going to simplify the top, and even though it's ugly, those messy root pieces are going to cancel, so that's kind of nice. But the 2 and the minus 9 aren't going to cancel. I can combine those to get x minus 7 over x minus 7 times square root of x plus 2 plus 3. I now can cancel the x minus 7s. I'm going to get the limit as x approaches 7 of 1 over the square root of x plus 2 plus 3. I'm going to do some plugging in here. 1 over square root of 7 plus 2 plus 3. This is 1 over square root of 9. That's 3, 1 over 3 plus 3. Just like one of the problems last time, don't tell me 1/9, tell me 1/6 for an answer over there. And this is our second method, rationalize the numerator. And the big clue that you're going to have to use this method is you see square roots in the problem.